The section 5.5, multiple angle and product to some formulas. Objective. You can pause to read, but I'm moving on to the next slide. This is more like key concepts, compute trig functions of special angles, solve trigonometric equations, verify identities. These are the double angle formulas. Before I continue with the formulas, just so you know, you're going to have to memorize all these formulas that you see on this slide. This is formula 1, sine of 2u is equal to what you see on the right hand side. Second one, cosine of 2u is equal to that. There's two more parts for part B, for cosine of 2u. There they are. Letter C, tangent of 2u is equal to that. In class, if you ask me to, I can show you how we can derive these formulas from formulas you have seen on the previous section. Power reducing formulas. Sine of square u is equal to this. Notice here we have a power. On the right hand we don't have a power. That's why we call it power reducing. B, C. Half angle formulas. This is the first one. Notice that you have, the reason why we call it half angle is because you have u over 2, or half of u, half angle. And on the right hand side of the equation here, you have a positive or negative. When do you use a positive? When do you choose the negative? The sign of the trig ratio depends on the quadrant that u is in. So for example, if you end up with a u in quadrant 2, since you have sine, and you know that sine is positive on the second quadrant, you use positive square root of this expression. If you have u in the third quadrant, then you know sine is negative on third quadrant, so you use negative square root of that, of this expression. Same thing for cosine. The sign depends on the quadrant u is in. And tangent, notice that you have two formulas for tangent and half u. This is the one that I like to use. Why? Because when you have a radical denominator, it's easier to get rid of it by just multiplying top and bottom by something. Over here, you would have to use the conjugate. You still get the same answer, but I like this one better. This next set of formulas you do not have to memorize. Product sum formulas, there's 4. In class, I can show you how we can derive these. Then we have sum to product formulas. There's 4 again. And then in class, I can show you how we can derive these. Number 1 says use the figure to find the exact values of each trig function. So you have this picture here. Notice that the reference angle is up here. You're given these two sides. They want you to compute sine of theta. Every single one of you should know how we get 13. So sine of theta is opposite over hypotenuse. That's how we get this. Cosine of theta, 5 over 13, adjacent over hypotenuse. Sine of 2 theta, this is theta. This is not 2 theta. This is 90 minus theta. How do we find f 2 theta given this triangle? What we're going to have to use, we have to use one of the identities I used out earlier. Sine of 2 theta is equal to 2 times sine theta cosine theta. We know what sine of theta is, cosine of theta is. Plug it in, multiply 2 times sine of theta cosine of theta from part A and B. Simplify, this is your answer. Cosine of 2 theta, again, we're going to use one of the formulas I used on an earlier slide. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. I'm going to substitute A and B, simplify, and I trust that you can follow the arithmetic here, and this is what we get. Tangent of 2 theta, I'm just going to take sine and cosine, sine of 2 theta and cosine of 2 theta. Use the quotient identity. Simplify this. There's the answer. Number 2. It says find the exact solutions algebraically of number 2. But you want the solutions only in this interval from 0 to 2 pi, including 0, not including 2 pi. What we do, we can expand this using the formula you saw earlier. And then at this point, you should notice that we have cosine of theta as a common factor. We pull it out. This is what we get. Notice that we have a product is equal to 0, and you have done this earlier, something like this on an earlier section. Set this equal to 0, set the second one equal to 0, solve for sine of x, and you end up with this. Cosine of x equals 0. That occurs at pi over 2 and 3 pi over 2, where you have sine of x equals negative 1/2. It occurs at 7 pi over 6, 11 pi over 6. Here's number 3. So if you look at this expression, notice that we have cosine of x is a common factor between these two terms in this binomial. So we're going to pull it out. And notice that we're left with 2 sine x, that becomes 2 sine square x, and then minus 1. Product is equal to 0, so we apply the 0 product property. Set the first factor equal to 0, second one equal to 0, but you have to do a little bit of algebra here, solve for sine of x, which means you have to take the square root of both sides, and we end up with plus or minus. Once we rationalize, we get plus or minus radical 2 over 2. And then we find where x is equal to 0 between 0 and 2 pi. That occurs at pi over 2, 3 pi over 2. Notice the same thing as number 2. Sine of x equals positive or negative radical 2 over 2. And that occurs at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We are done with number 3. Number 4 says find exact solutions algebraically. Same restriction as number 2 and 3. So what we're going to do here is we're going to FOIL. Once we FOIL, we get this. And you should notice that this becomes the Pythagorean identity, which is equal to 1. And you leave this alone. Take away 1 from both sides. You end up with just this equals 0. And then at this point, you end up with this. Sine of 4x equals 0. Why? Because you're applying this formula that you saw on an earlier slide. From here, notice that you have a multiple angle. So then you do 4x equals, where do you get 0 for sine? Add 0, and then every pi units after that, that's what we have, pi n. Since I'm looking for all answers between 0 and 2 pi, first I need to solve for x. This is what I get. The 0 goes away. And then I'm going to start plugging in values for n. N equals 0, 1, all the way to 7. And that gives me all these answers. So the answer to number 4, given this restriction, is equal to this. These are all your solutions. Notice that again you have restrictions here. So what I'm going to do is I'm going to move this cosine of 3x to the other side. Again, I notice that I have a common factor of cosine of 3x. I pull it out. This is what I get. Product is equal to 0. 0 product property. I set this factor equal to 0. I set this factor equal to 0. This gives me cosine of x equals 1, which I know that the x value between 0 and 2 pi is just x equals 0. How come I don't say 2 pi? Because 2 pi is not in the interval. You cannot include 2 pi because of this parentheses. So that's why we include 0. That's why we say x equals 0, because 0 is included. And then at this point, I go to this other one. Notice that it's a multiple angle. So then I have 3x equals the first x value, the first angle in which cosine is 0 is pi over 2, and pi units after that. That's why I have plus pi n. I need to solve for x, so multiply both sides by 1/3. And this is a binomial, so I need to multiply this binomial by 1/3, and I end up with this. Do I stop here? No, because I need to find all the restrictions between 0 and 2 pi. So I need to start plugging values for n, starting with n equals 0, all the way to I end up with something that it gives me outside of this restriction, and after 5, I end up with something out of this restriction, so then I stop at 5. And that's how I get all these answers. Plug in n equals 0, n equals 1, all the way to 5, and we'll generate all these answers. So what is the answer to number 5? This plus this. So here it is. These are all your solutions of this equation within this restriction. This is number 6. We need to use the half angle formulas to find sine, cosine, and tangent. First thing we're going to do is we're going to see that pi over 12 is equal to 15 degrees, and I know that this is in quadrant 1. So this angle is in quadrant 1. So to compute sine of 15, or sine of, using the half angle formula, 1/2 times 30, I apply the formula that you see there. Notice that since 15 is in quadrant 1, I am going to be using the positive expression. I plug these values into the formula, simplify. I do a little bit of pre-algebra here with these fractions that you see here. This is what I get. At this point, I notice that I do not have the same denominator, so I multiply top and bottom by 2. This is what I get. I give each of these its own radical. That's what I get here. And I know this is equal to 2. Cosine of 15. Similar process. This is the formula that I'm going to be using. Again, 15 in quadrant 1. Use a positive expression. Substitute. I am going to skip some of the steps here, but I trust that you're able to get the following equation and the following expression here. Tangent of 15. I am going to use this formula. When I substitute the information into this formula, this is what I get. I simplify. At this point, I notice I have a fraction in the denominator, so I multiply top and bottom by 2. I have a binomial in the numerator, so I need to multiply the 2 times the 2 terms. That's why I need a parentheses, and this is the answer. Here's number 7, same directions as number 6. First, what we're going to do is we're going to change this to degrees. I notice that this is 105, and 105 is in quadrant 2. Sine of 105 is the same thing as 1/2 of 210. And notice that 105 is not one of those special angles in the unit circle. That's why we're using this formula. Since I want to use sine, this is the formula that I'm going to be using. I notice that I have an angle in the second quadrant, and sine is positive on the second quadrant, so I'm going to use a positive expression. This is what I get. Notice that this becomes negative radical 3 over 2, but you have a minus here, it becomes plus. Simplify this. I get the following once I write the same denominator. And from here, you should be able to follow that we get this. Cosine, this is where you have to be a little bit careful. Again, this is the formula that we're going to be using. And this is what I get. Now, I know that I'm in quadrant 2. That's why. And sine is negative in quadrant 2. That's why I need to include this negative. I use the negative expression. From here, I just simplify. I'm going to skip those steps. I trust that you can follow and end up with this result. So this is cosine of 105. Tangent. This is what you get using the half angle formula that you see here for tangent. I substitute the values. And notice that I don't have to worry about the sign because this formula takes care of the sign. Simplify. At this point, I multiply top and bottom by -2. And that's how I end up with this. Here's number 8. Here we have to verify the identities. So what I'm going to do is make one side equal to the other side. Notice that the right side looks more complicated, so I'm working on the right-hand side. Reciprocal identities. The numerator becomes this, the denominator becomes this. At this point, I am going to multiply top and bottom by cosine squared theta. And when I do that, this is what I get. The numerator becomes 1. The denominator becomes 2 cosine squared theta minus 1. At this point, I get the following. Why does this become this? Because this is a formula you saw on earlier part of the video. And then from here, using the reciprocal identities, I get the following. And I'm done with number 8. Number 9, this one's actually pretty straightforward. You can do this problem, but it'll be more complicated if you go a different route. So this is what I do. I notice I have 2 of these, so then I rewrite it as the sum. And notice if I take this sum of these 2 expressions, I get this. From here, I notice that this is the same thing as sine of 2b plus 2b. From here, I notice that 2b plus 2b is equal to 4b, and I'm done with number 9. Here's number 10. What you're going to be doing here, you're going to be using the formulas that you're going to have to memorize. So this is the first formula that I'm going to be using. I am going to be using this formula in the numerator, okay? And then I'm going to be using this formula in the denominator. When I apply these two formulas, this is what I get, okay? I'm substituting. For x, I'm using 3 theta. For y, I'm using theta. Plug it into both of these formulas. This is what you get. From here, I just simplify this. 3 theta plus theta is, I know it's 4 theta divided by 2. 3 theta minus theta, which is 2 theta divided by 2. Once I simplify that, I get the following. And notice that this goes away. The 2 goes away. And I have sine of 2 theta, cosine of 2 theta, negative, which gives me what I want it to equal on the right-hand side. Moving on to number 11. I'm going to be using this formula. And again, this expression here is going to be like the x. This expression here is going to be like the y. So I plug this information into the right-hand side. This is what I get. I simplify this. Whatever this is divided by 2, whatever this is divided by 2. And I trust that you can follow how we get pi over 3 for this and how we just get beta for this. At this point, I know that cosine of pi over 3 is 1/2. 2 times 1/2 is 1, or just cosine of beta. And I'm done with problem number 11, and this is the end of this video.